All right, lesson 2.6, computing function model validation. It's our skills and learning objectives for this lesson, and we're going to find an appropriate regression model for a data set. We're going to use contextual clues to determine an appropriate model, recognize a correct regression model using the graph of the residuals, find the residual errors of a model, and analyze the findings as underestimating or overestimating the data set in context. All right, so lesson 6A says in this lesson we will explore how to construct linear, quadratic, and exponential models based on a data set. We want to focus on whether our model can be justified as an appropriate for the data set by using the graph of the residuals of the regression. So example 1 here says Darren injured his hamstring in a football game. His sports trainer sent him to physical therapy to build up his leg strength by using a regulated weight machine. The table and the graph show the number of repetitions he has been able to do on each day as he was in PT. The best fitting linear function, y hat equals 2.05x plus 4.95, is also shown. We can use this line to find the residuals. And so we can see there that they give us a group of ordered pairs and that they plotted those points of the first graph on the right. Then A says use the line of best fit to find the residuals. So if you look at the next graph on the right there, the second one, you'll notice that now it's got that regression line. All right, so now we're going to use that line to find those residuals. So first thing we're going to do is we're going to sketch a vertical line at x equals 5 and at y equals 18. So x equals 5, y equals 18. Whoops. All right, so then it says to draw a red line to show the length of the residual, which is our actual value minus our predicted value. So right here was our actual value, and we're going to draw a line between it and that line of best fit. That is the residual. And so we can do that on each one of them. Well, so a residual is going to be the difference between the observed y value and the predicted y value. So it's the actual minus the predicted. It is a vertical distance from the actual plotted point to the point on the regression line. Then it wants to complete the table below to calculate the y hat values, so the predicted values, the residuals, and the squares of those residuals. So we're going to go through here, and there's different ways to do it, but remember they told us that y hat was equal to, let me look up that equation again real quick. So it was 2.05x plus 4.95. So we could just, if nothing else, we can type that in y equals, we can go to our table, and we can look where x is 1, 3, 5, 7, and 9, and pull those values off. And so at 1, it's 7. At 3, it's 11.1. At 5, it's 15.2. At 7, it's 19.3. And at 9, it is 23.4. Then it wants us to take our actual values minus our predicted values. So that's going to be those residuals. So we're going to take the y minus the y hat, so 7 minus 7, 10 minus 11.1, 18 minus 15.2, 17 minus 19.3, and 24 minus 23.4. And then it wants to take those values and it wants us to square them. And so this is just our squares of the residuals. So we have 0 squared, negative 1.1 squared, 2.8 squared, negative 2.3 squared, and 0.6 squared. Okay, and then mine, it asks for a sum. And so on here, if we do the sum of the residuals, we add all those numbers up and we get 0, which remember, that is the residuals is the distance between the actual point and the regression line, and so we want that to be close to 0, because the closer to 0 is, the less error we have. And then we can add up all the squares of the residuals here, and it comes out to like 14.7. All right, so then some vocabulary and definitions. It says, given the data point xy, the deviation of a data point is y minus y bar, which is the directed distance from its y value from y bar, which is the average of the y values. So they're going to take the average of the y values and they're going to draw in that, they're going to draw in that line there. Okay, so there's my average of my y values. They averaged them all up. They got y bar and they drew a horizontal line in there. The deviation of the data point is how far is that data point from that line. So if we're looking at the one above, if I'm looking at this data point right here that I'm trying to make red, this is not working for me here. There we go. It's going to be how far apart those two are, okay? That's the deviation of the data point. The residual of the data point, though, from the regression line is the distance it is from the regression line. So it's a vertical distance between the y value of the point and the regression line. Residuals help to determine if a curve is appropriate for the data set. The better the smaller the residuals, the better it's going to be. All right, and then the difference between the predicted and the actual values is the error in the model. So any difference between the predicted and the actual, so the residual amount is our error. The only difference is they switch it. So if you notice down here at the bottom, the residual is your actual minus your predicted, and your error is the predicted minus the actual, because you want to know how far off is that line. So you're going to put the predicted one first, because the predicted is the line. All right, and then above those two, it says the regression line of best fit is your least squares regression line. All right, so we're going to use the data at the right to create a residual plot. So the first thing we need to do is we need to put this in our stat edit, and we need to go run regression. All right, so you're going to go to your stat edit. Put your x's in L1, your y's in L2, and then remember now, it didn't tell us here what kind of a plot we were looking at. It didn't tell me if I want to run linear regression, quadratic regression, exponential regression, whatever kind of regression, okay? So we need to go look at it. And so in order to do that, after you put your data in, you're going to go to the second y equals, turn on plot 1, and then you want to make sure that your x list is in L1 and your y list is L2. And then you can go to zoom, and number 9 is zoom stat, and that will let you see those points. Okay, so when you look at these points, they're really kind of weird, but they are increasing. So I think there's like a couple here and one here, something like this. So it is kind of tricky. That's not it. I'm going to pause this for just a second and pull them back up because I didn't write it down. Okay, so when I go to graph this, is I point here, 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 and somewhere over here. All right, so it doesn't really look linear. I don't see any particular type of pattern that's obvious in there. So let's just try linear. All right, so then let's go run our linear regression. So remember, this is where we're going to go to stat, go over to calc, and linear regression is number 4. I'm going to paste it into y1, so alpha trace y1, and calculate. All right, I have to run regression in order to look at the residual plot. So I'm going to make note up here. You must run regression to have residuals. Okay, now if I want to look at the residuals here, it tells us we go to stat edit. We could put our x's and our y's in, which we already did, okay? And so at this point where we're at, because we went ahead and we ran regression and we looked at it to see did it look linear, quadratic, or cubic, or exponential, whatever, And then we went ahead and chose linear regression and we ran it. So after you do that, then you can go to second y equals and go into plot 1 again. Turn it on if it's not, okay? So then go down. Ours by default is on scatter plot. And then we want to, or they graphed it there. I don't know why they did it backwards. I'm sorry. I just can't read. My notes did not have all this. So we have actually done all the way to here. I apologize. Lied again. We've actually done down to here. We've done everything. Yeah, mine is totally different than this. And so I'm sure yours is too, actually, because my notes came the same thing as your notes. So we're going to have to make some adjustments. So this is what's going on. All right, so this is what we just did, actually. Okay, this is what I wrote down here at the bottom. I apologize. I did not catch that the teacher notes were different than our student notes. All right, so this is everything we just did. Now, if I want to look, let me see something real quick here. Here we go. All right, so we did that. We looked at it. We said we were going to run linear regression, and we did it. We've got an idea what it looks like. So we've done all of this. All right, then to do the residual plot. So we're going to go back into our second y equals. Go back into plot 1. But this time we're going to go down to the Y list and we're going to change that to residuals. So to get to residuals, you're going to go to second stat. And it's not always number 9, okay? Mine's number 7 on mine. If you have some other stuff, turn on your calculator. It might be number 8 or something. So go find where it says residual. And then to graph it here, we're going to actually use Zoom 6 because we changed our window in order to be able to view the others, the actual data. And so it might not show everything we need. So if we hit Zoom 6, that takes us back to our parent window. Now I can see my equation still on there. So like mine has an equation here and we don't need it. So if it's bothering you, go into Y equals. Remember we talked about how to turn things off and on in our Y equals. So take your cursor over the equal sign and hit enter. And then you can hit graph. So when you do that, you see a plot there of your residuals. What we're looking for on these residuals is we don't want a pattern. If there's a pattern, then that means that we picked the wrong regression to run. But if there's no pattern, then it means it's a decent regression. So this one, I don't see any pattern in our residuals, so that means that our regression was okay. And then if you want to actually see your residual values, you can go back to your stat edit. Go over to L3 and you have to go up on L3 and then put residuals there. So second stat residuals and hit enter and it gives you those residual values for that point. All right, so the residual point is just a scatter plot that shows the residuals on the vertical axis and the independent variable on the horizontal axis. So our x's are going to stay the same, but our y's are now going to be the residual values. We'll use the residual plots to help us decide whether the model chosen is an appropriate model. So they're not really using the one that we just did because it really wasn't that great of one, but they're using the one from the first example. So notice the residual plot below for our example where y hat was equal to 2.05x plus 4.95, and that the residuals are randomly placed above and below the x-axis. So we can see here that there's no pattern going on. We have some above the x-axis, some below the x-axis, and we even have one that's on the x-axis there, okay? So that's what we're looking for. What we don't want to see is a pattern. So if you look at the next one there, it's got that U-shaped. That means that that's not really a linear function, okay? If we see some pattern, then that means my regression equation is not the best one. So I would need to change it. So no pattern is the best thing. All right, so let's look at the data point with the least squares regression line and analyze the associated residual plot for example 3. It says use a red pencil to draw the line segments from the data points to the line of best fit in the graph at the right. Our regression equation is y hat equals 0.83x plus 0.4. So here's my residuals. These residual line segments fall above and below the regression line. What does this tell you about the value of the residuals? Well, the residuals can be positive or negative. So if they're up here, then my residuals are positive because my actual value is more than the predicted. And if my residuals are down here, they're going to be negative because my actual is less than my predicted. All right, so how do we know if our predicted line overestimates or underestimates the data? Use the residual plot of the data set to complete the statements. So the predicted line will blank data when a residual value is positive. So if my residual value is positive, that means it's higher, which means the predicted line is lower, so it's going to underestimate. And then the predicted line will blank data when the residual value is negative. If the residual value is negative, that means that my actual is below, and so my regression line, my predicted line, is above, it's over it, so it's going to overestimate the data. All right, so in example 4, suppose the data have been measured for two related variables x and y. Enter the data in two lists in your grapher. Show via linear regression that the best fitting linear function is y hat is equal to 1.52x plus 2.35. Then it wants us to record the coefficient of determination, the r squared. And so I think your note says something different, so you do need to change it because we're looking at r squared. In order to get r squared to show us on our calculator, we're going to go to second, 0. That is our catalog. Now we're going to go down to the D's because we want diagnostic on. Now instead of scrolling all the way down to D, when you hit second 0, your alpha button is turned on. If you will go hit the x to the negative 1 button that has a D in green above it, it'll take you to the D's, and then you just have to scroll down to diagnostic on. Choose it and then click enter. It has to say done for it to actually be turned on. All right, so let's go put these data points in our stat edit. So you might want to clear your calculator, and if you do that, go turn that diagnostic back on. Double check your numbers. All right, and it wants us to find that equation. So let's go to our stat calc linear regression. I'll go ahead and paste that into my Y1. And it's rounded values, but I did get the same equation. My diagnostics on. So if you notice that r squared, it says it's 0.97500937884. The closer that value is to 1 or negative 1, the better fit that line is going to be. So this is like 97.5% fitting our line. It's pretty high, okay? So that's good. Wants us to complete the table by finding the regression points. So I'm going to actually go back to my stat edit. And in L3, I'm going to go up on L3. And I'm going to go type in my equation. So I'm going to go type in the 1.52, but I'm not going to put an X because my X's are in L1. So I'm going to go to second and the number 1 plus 2.35 and hit enter. And so that's going to give me my y hats, okay? So I know that the first equation is going to be 4 and 8.43, 7 and 12.99, 10, 17.55, 13, 22.11, and I'm going to keep going. And then my residual points, which remember is my y minus my y hat. But I'm just going to go up on my L4, and I'm going to go to second stat residuals and hit enter. And it says around these to 3 decimal places. So I got 0.582. Oops, it's a point, so I need to put the x value there, excuse me. So 4 comma 0.582. 7 comma 1.030, 10 comma 0.479, 13 comma 2.927, and just keep going from there. All right, so that was D. And then E says make a scatter plot of the data on your graphing calculator. On the screen, plot the predicted Y. How well does a linear function fit the data, and explain how you know. All right, so I'm going to turn on my stat plot. So second Y equals. I'm going to go in and make sure that my X's are in L1 and my Y's are in L2. So mine was stuck on the residuals from before, so I needed to change that. All right, so make sure your Y's are in L2. Your Y list is L2. Then I go to my zoom stat. I can see my data points there, and I can see my line. My line goes right through them, fits really well. So how well does a linear function fit the data? It fits it really well. We could also check looking at the residuals. So go to second Y equals. Now go back into plot 1. Change that Y list to residuals. So second stat residuals. And then zoom 6. Which now I remember looking at my points that went all the way from 4 to 31. So I am going to extend my window, my X's out to, I'm going to just go ahead and go to 50. And so I can see my residuals there. So the residuals, oops, look like something like that. So there is no pattern to it, okay? So the residual plots are random. plot is random. So y hat function fits the data pretty well. We also know that r squared was equal to 0.975, which is near 1. That also means that it fits the data really well. All right, then example 5 says the table below gives the wavelength x in meters and the wave speed y in meters per second of deep ocean waves. Explain why a quadratic function would be expected to fit the data well. So I'm going to clear my calculator. I'm going to go put those data points in my stat edit. Double check them. And then I want to go look at my plot, make sure that my Y list is in L2. It is. So then zoom stat. And so what I see here, whoops, I didn't turn my pen on. What I see here is something like this. And so I can see it looks like the right side of a quadratic, okay? So what we're seeing there is that the data is increasing and it's concave up. So it's looking like it's this piece of a quadratic. And so it tells us to find a quadratic regression. So stat calc quadratic regression. I'm going to paste it into Y1. And so we got y hat equals 0.747x squared minus 1.231x plus 3.040. Record the coefficient of determination, the r squared. I did not turn my diagnostics on, so I have to go in and do that. So second 0, D. I'm going to scroll down to diagnostics on. Hit enter to choose it, enter to turn it on, and then I'm just going to go back and run that regression again. And so I can see that my r squared then is 0.9996. So it's really close to 1, so that's good. D says find the residual plot for the data. Based on the residual plot, could the quadratic function be used to make predictions of deep ocean wavelengths to the nearest meter if this accuracy were necessary? Explain why or why not. All right, so let's go in. Let's look at our residuals. So I'm going to go to my second y equals. I'm going to go change my y list to residuals. So second stat residual. I'm going to go to zoom 6. I'm going to look at my x's. They go from 3 to 10, so I see all my points on there. And so what I'm looking at is I have a point here, here, looks like on it, below it, and then right about at it as well. So the residuals, there's no pattern. The residuals are close to the x-axis. So yes, this would make a good, the quadratic function could be used to make predictions. So random residual plot. All right, then example 6. It says the total number of views for a popular podcast is increasing. The table shows the estimates of the total views each month since January of 2010. Use a graphing calculator to find a quadratic, exponential, and power regression model. So we're going to put this data into our stat edit. So if you want to clear your calculator, do so. Also, if you clear it, go turn your diagnostics on. All right, so put my months in L1, my total views in L2, and then I'm going to go run quadratic regression. And so when I do this, I get the equation 0.013x squared minus 0.205x plus 0.843. And I'm going to come over here and I'm going to put the r squared value. And so the r squared value here is about 0.97. Then I'm going to go run exponential regression. And what I did is a quadratic regression, guys, I stored it in y1. And so when I run my exponential function, I'm going to store it in y2. And then power, I'm going to store in y3. So I have them all there if I need them. All right, so my exponential model, so stat calc exponential, store in y2. And I get 0.239 times 1.110 raised to the x. And it has an r squared value of 0.98. And then the power model, I'm going to go run regression. And I get 0.116 x raised to the 1.155 with an r squared value of 0.87. B says use the residuals. Use a residual plot for each regression model. Do the residuals follow a definite pattern or are they randomly scattered? All right, so, my residuals are the residuals that are in my calculator are the last regression that I just ran. So it's actually going to be the power one. So let's go look at it since it's already in our calculator. So I'm going to go to my second, y equals, turn on that plot. Go down to my Y list, put my residuals there, and so then zoom 6. And so what we see here is that they're concave up and increasing, kind of looks quadratic. So we have a quadratic pattern going on. All right, then real quick, I'm just going to go run that exponential regression again so that my residuals are saved for exponential. Then I'm going to, because I already have my stat plot where my residuals are my Y list. So just go ahead and go to graph. And so here it's just kind of random. Then go through and run your quadratic regression again. And then go to graph so we can look at those residual values. And again, that one's going to be kind of random looking. So based on your findings, which model fits the data and explain why? Well, we can tell it's not the power. It has a pattern in the residual. In the residual plot. Okay, so it's definitely not the pattern. Power. So we would have to choose between the exponential and the quadratic. And they both are just kind of random. So I'm going to use the r squared to make that decision. And the best r squared was for my exponential model. All right, the exponential model, since the residual plot is random, or scattered, or whatever you want to call it. And r squared is closer to 1. And then D says, using the model chosen, what is the expected number of views in 5 years? But just be careful because remember our X's are in months. And so 5 years is 60 months. And so we're just going to take that equation that we got, which we stored in our Y2. So we're going to take y of 60 And so if nothing else, you can go to your table, and if you go to second window, that's your table setup, and if you'll do your table start at 60 and then go to your table, it'll show you, just make sure you look in Y2, and it should tell you 124.61 million views. And that is the end of part A.